Hello everyone, this is Koji from iPSCells. Today, we'll be covering the future medical lab.
So, Koji, what is today's theme?
Today's theme is about whether aging can be stopped.
I'm very curious about this. Since this is something everyone is concerned about, could you walk us through it?
To get straight to the point, I don't think it's possible for a person to live to 5,000 years old. The reason is that the history of humanity is incredibly long. Within that history, there have been countless people. Statistically, if someone could live 5,000 years, we'd have seen it by now. Even someone claiming to be 20,000 years old. But they definitely don't exist. Interestingly, the survival curve of humanity drops sharply between the ages of 125 and 130, and we can't go beyond that. So the question is whether aging can be stopped, and whether anyone can reach 125 or 130 years old. That's a bit difficult with current technology. But whether someone can stay genuinely healthy all the way to that age, I think the answer is yes. In America, aging is viewed as a disease, one that we haven't been affected by until our 20s or mid-30s. We managed to grow up just fine. I see it as a disease that peaks around 30, with aging setting in around 40, and it progressively advances until about 80. So the current research suggests that this disease can be slowed down, or even partially reversed. Anti-aging and longevity research is also progressing worldwide. It's really advanced. The current direction of investment is heavily focused on AI and aging research. In English, this field is called longevity.
First, I want to ask about aging. Specifically, whether there are things that can be done beyond 120 years. There has been talk that aging itself is a disease, but what actually happens in our bodies during aging?
Before we talk about aging, we need to understand what our bodies are made of. If we were made of metal, we would rust and deteriorate. But we need to know what our cells are made of and what causes them to deteriorate. Our bodies are made up of units called cells. You may be familiar with cells. There are single-celled organisms from ancient times, squirming around as a single cell. These cells gathered together to form a collective that created animals and life. Our bodies are made up of a collection of cells that number between about 36 trillion and 60 trillion. In other words, when something goes wrong, aging occurs because the cells deteriorate. So, why do cells deteriorate? That's what we need to understand. Well, there are several reasons. The first one is that DNA deteriorates. The reason it deteriorates is that cells divide every single day. When you wash your body in the bath and dead skin comes off, those cells are being replaced. When cells divide, they can make mistakes that lead to damaged DNA. Mitochondria, which are crucial for cellular activity, are responsible for producing energy. That process also generates cellular wear and tear. There's been a lot of talk about autophagy lately. Proteins are continuously being produced and broken down inside cells every single day. However, as cells age, this breakdown process doesn't happen properly. The cell's cleanup system starts to fail. A lot of aging substances accumulate in the cells of the body, and that causes the cells to deteriorate. So, simply put, healthy cells can easily become senescent cells. In our daily lives, it's not necessarily a bad thing for cells to become senescent. In fact, if they don't, it can actually be dangerous. The reason is that when cells make mistakes and turn senescent, they stop dividing, which helps prevent cancer. So, even though our cells make a lot of mistakes every day, we still manage to live for about 80 years. What happens is that there is a mechanism in the body that either keeps in check or clears out slightly damaged cells. This keeps happening more and more every single day. But as you get older, when you produce too many senescent cells and they accumulate in your body, it shows on the outside, making it obvious that aging has taken hold. For example, as long as the stem cells in the skin are actively producing skin cells, the skin won't become wrinkled. However, when they get a bit tired and the number of senescent cells increases, that's when the skin starts to wrinkle. When we talk about aging in the body, it would be fine if these senescent cells just stayed dormant. The most important thing is that these senescent cells cause inflammation. When inflammation occurs, it releases a lot of inflammatory cytokines, which is a big problem. Inflammatory cytokines are released in large amounts due to senescent cells. As a result, it causes other cells to become senescent as well, and that's how aging progresses rapidly. The problem is that this loop keeps going around and around. So, to summarize, all kinds of things happen inside cells every day, wearing them down over time. Becoming senescent is the body's way of preventing disease. But once cells turn senescent, they cause inflammation. And as a result of that inflammation, more senescent cells are created, leading to the body's aging. This is the mechanism of aging, and there are many interesting studies on this. The more the body ages, the higher the concentration of inflammatory cytokines throughout the body.
But you don't feel inflamed at all, do you?
Even though there is no inflammation you can feel, cytokine levels are high, and yet there's no way to tell the body it's producing too many. That's why the concentration of inflammatory cytokines keeps increasing. They end up producing a lot of senescent cells again. That's related to aging. In mouse experiments, they're creating mice that are born without some of these inflammatory cytokines. That can actually extend lifespan. What's even more interesting is that if you eliminate inflammatory cytokines in slightly aged mice, it can also extend their lifespan. So it's becoming quite clear that inflammatory cytokines are related to lifespan and aging. There have also been experiments on senescent cells. In mouse experiments, since such things can only be done with mice, there is research showing that removing senescent cells can extend the lifespan of mice. Currently, there is a popular idea that if we keep eliminating senescent cells, known as senolytics, it might lead to an extension of lifespan. A lot of this research is advancing through mouse studies.
How long do you think it will take to make that practical for humans in the future?
Well, pharmaceutical companies are really working on creating drugs to cure aging-related diseases, so there's a real chance it's achievable. The first direction is using substances with anti-inflammatory effects, meaning stopping inflammation. Another is eliminating senescent cells. Various senolytic drugs have been developed that can specifically target and destroy these senescent cells. So that's the approach of fixing it directly. Another approach is to use components extracted from young stem cells to supplement those young factors. And it seems like we could create about 3 types of exosome preparations. Right now, there is a significant focus on these approaches to aging. Another thing is that in America, they are doing things like gene manipulation to stop aging. The Yamanaka factors reprogram cells to a youthful state, essentially creating iPSCells. If those Yamanaka factors could be introduced throughout the body, even briefly, aging might stop. In fact, there are currently studies being conducted on drugs that can prevent aging.
When you hear drugs, are you referring to something like oral medications? Or are you talking about injectables? Both are being considered, right?
Yes, both oral and injectable options are being considered. Low molecular weight compounds are stable enough to take orally, but unstable substances may require injection. If it's genetic manipulation, then we really have to inject it. So both approaches are on the table.
When this actually becomes reality, that would be huge for both middle-aged men and women. Isn't it really groundbreaking? Isn't it almost too good to be true?
Well, that's the thing. The words longevity and health might sound a bit old-fashioned these days. The old image was something like, I'm just an old lady hanging on for dear life. But that's not what longevity research is about at all. It's about extending healthy life expectancy. It's not just about barely surviving. I might not be able to surpass 125 or 128 years, but I'm working on staying healthy all the way up to that point. This is a really important topic. Do you all know how much of a difference there is between healthy life expectancy and actual lifespan? There's a period when people can no longer live the way they want, when they're suffering, perhaps bedridden. On average, in Japan that gap is about 10 years, while in the US it can be as long as 15 years. So while extending lifespan is important, staying healthy until the very end, even just adding 10 or 15 healthy years, is already huge. That's exactly what longevity research is focused on right now. Extending healthy lifespans means not only that the body rejuvenates, but also that people can keep contributing to society longer. Working careers will likely extend. That will change how society is structured in a big way. Socially, this is enormously significant. Right now, someone might still have all the knowledge and drive, but once the body gives out, they have to retire. Even with the ability, if cognitive function declines, retirement becomes unavoidable. But if those people are healthy and sharp, all that accumulated knowledge stays in circulation, and that could lead to massive structural change.
But doesn't that mean there will be no place for young people?
Not at all. If anything, the opportunities to learn from those people will increase, which I think is incredibly valuable for society. Especially in Japan with its declining birth rate, having people stay active is a real benefit. That's genuinely something to celebrate. Now, regarding aging, these advancements are very likely to come in the near future.
Are you actually involved in the longevity field as well? Activities that iPS is currently working on?
We are indeed using iPSCells, and iPSCells are essentially your own rejuvenating stem cells. You can obtain cells that are as young as when you were 0 years old. We're using those cells for multiple rejuvenation applications. Another area we're working on is with Kose, a cosmetics company, and Reju, a longevity-focused company. Using iPSCells and product development, we're actively researching how iPS cells can be applied to longevity.
So iPS cells are really being put to use for rejuvenation?
Absolutely. There are already several major global companies starting clinical trials using iPS cells for longevity. The market cap on some of these companies, before they've even released a single product, is already over 100 to 150 billion. So there's no question that iPS cells will play a role in both regenerative medicine and longevity. The practical application of iPS cells and longevity medicine, as this research advances and access for the general public opens up in parallel, it will provide major benefits for people's health span.
Exactly. Including myself, I think we'd all like to look forward to that kind of future.
So, today's summary covers 3 points. First, aging is a disease that everyone will experience. Second, research around the world is progressing on ways to stop aging, slow its progression, or even partially reverse it. Third, among these approaches, iPS cells are rejuvenating stem. Today, I've shared just how promising iPS cells really are. This channel will continue to share information about the future of medicine and the latest advancements. By sharing this content, you help create a more informed world. So please follow us and leave a like. It really helps.